Okay, so for a cone, as I told you that you have a slant height, you have a height, and you have a base radius. Okay, so you have base radius here. This is called your height. Okay, this is your L, slant height.
Plant height.
This is your height, H, and this is your radius. I told you that volume of a cone is 1/3 pi r square h. Also, what I told you, the fundamental relation that this forms a right angle triangle here. This one is a right angle triangle. So you can write hypotenuse square, L square, is equal to perpendicular square plus base square. Okay. So this is the volume of a cone. Next, the lateral or the curved surface area. Lateral or the curved surface area except the circular base. What is the area? Pi r L. Where L obviously how will you find? If the height and the radius is given, then you can find L with the help of this relation. Okay. And finally you have total surface area. Total surface area is your lateral surface area pi rl plus the radius of the area of the circular base. So pi rl plus pi r square. So if you take pi r common, you get r plus l. These three are the relations that you must remember. As far as hollow cone is concerned, the case 2, in case 2 can you can omit this case 2. If you understand the case 2, it's fine. Otherwise you can omit case 2 also. Okay, because hollow cones normally questions you don't get. Okay, so that's what. And let us move on to some of the problems related to cones. Hollow cone is also very similar to your hollow cylinders, so no problem with that, I think. Okay, not any problem, but one very important case we are going to discuss here. If you remember, I sent you the video of this, that if a semicircular piece of paper is rolled to make a cone. Here I am talking about the an arc, the sector of a circle. This sector can be a semicircle also, no problem. Okay, so you have a sector of a circle, paper in this shape, any sector. This may be a semicircle also. I sent you the video where the semicircle was being a semicircular piece of paper was being made into a cone. If you have seen that video.
Yes, sir.
So in that uh, video, you see that this is the radius here, whether it is a sector of a circle or whether it is a semicircle. When this is made into a cone, okay, then what happened? This slant height becomes your radius. Okay, that is slant height L. This becomes a radius. Also, the length of this arc here, this arc, or when you're considering this, you consider this arc. The length of this arc becomes your circumference of this circular base. Okay, so if I call AB, AB, so arc AB, this arc AB of the sector or the semicircle must be equal to circumference of the base of the cone. Okay, that is what. Now, a right angle triangle can be rotated. I think I showed you this. No, I didn't show you. A right angle, the basic definition of a cone is that if a right angle triangle is rotated about one of its sides, other than the hypotenuse, remember. Okay, and I'm not sure whether I have the video of this. Just let me check. Yes, I have. I don't think I have shared this video. I'm sharing this video. Just check this video once. Just check this video. It's a very short video. Just see it, and you'll get an idea.
Yes, sir. Seen.
Did I send you this video earlier?
No, sir. It was circle.
Okay.
It was not circle. It was a cylinder.
Yes. Yes, it was a cylinder, and once I send you a semicircle, how to make a cone out of a semicircle.
One. Yes, sir. The
Sir, yes,
radius.
sir.
Yes,
But I
sir.
don't think I have sent you this.
No, sir. You
No,
didn't
sir, you
send.
haven't.
Hmm. Okay, one more. I'll make an announcement about the test next week. Okay, when I am through with this.
So when are we getting a Diwali holidays?
I think it should be on Friday. Friday is Diwali starts. I think. I asked someone. He said Friday should be
Sir,
the
which chapter test you will take?
Friday. Huh?
Which chapter? About
I'll
what
send it
test
to
are
you.
you
I'll
talking
send it to
about?
you in the group. Okay, I'll take a test on quadratic equations next week. Okay, it should be on Wednesday. Let's see. I'll send you a
Sir, chapter.
quadratic equations.
Thank you, sir.
Okay, so let us start with the problems here. First problem is find the length of the canvas 2 meter in width is which is required to make a conical tent 20 meter in diameter and 42 meter in slant height, allowing 10% for the folds. What do you mean by 10% for the folds? 10% for the folds means it is a sort of wastage you can consider, because at the ends when you're applying the folds, okay, especially the girls must be very aware of this because their clothes have folds at the ends, to make it heavy so that the weight is towards the towards the down, so that with air it does not blow. So that is why these folds are given, okay, to make the edges stronger so that it does not start tearing, and besides to keep a little weight also on the cloth. Okay, so these folds, they consume a little bit of cloth, right? And that cloth is actually wasted because you are giving double folds there. So we will consider these 10% for the fold, mean 10% of the cloth is being wasted. Okay, and the stitching, 10% for folds and stitching. So in stitching also some cloth is wasted. In cutting also the cloth is wasted. Also find the cost of the canvas at the rate of 80 per meter. So the my aim here is to find out, suppose this is your canvas. This is your canvas, okay, 2 meter in width. From this canvas I'm going to make a tent, a conical tent. Okay, and this conical tent that I am making will be 20 meters in diameter. This will be 20 meters in diameter and 42 meters in slant height. So from here up till here, this should be, oh, slant height, 42 meters in slant height. Okay, so this shouldn't be the slant height. So slant height here is this 42 meter in slant height. Okay, allowing 10% for the folds and stitching. And the cost of the cloth is given, that will determine after we have determined the length of the cloth that is required. Let us suppose that the length of the cloth that is required here is L to make this tent. Okay, now what is the, when we are making a tent, what do we require actually? Do we make the, do we put the cloth in the ground also on the tent? Inside the tent, do we put the cloth on the ground also? Tell me, a very common sense question. When you are making a tent, inside the tent on the ground, do you put a cloth?
No, sir.
We don't put a cloth.
No, sir.
That means whatever cloth that we are using, that will be used only to make the walls of the tent, right? That means we are talking about the curved surface area of the tent. So we'll first find out the curved surface area. But in order to find out the curved surface area, what do we require? What is the formula for curved surface area? What is the formula for curved surface area of the tent? Pi RL. And do we know the slant height? Yes, we know the slant height. So curved surface area of the conical tent is equal to pi RL. Okay, now you put the values, pi into R, radius, the diameter is 20, so radius is 10, 20 by 2, and the curved surface area is 42. So this will cancel with this. So it's simply getting, and this will cancel here. We are getting 22 into 10 into 6. Okay, this is the canvas that is required to make the tent. But the problem here is that we not only required this, but we are wasting how much? We are wasting 10%. So what is the wastage here? Wastage here is 10%. Of what cloth? Of the cloth that we are using to make the tent. Okay, so 10% is being wasted. So this comes to 132, okay, meter square. So this much cloth is being wasted. So what is the total cloth required? Total area of cloth required. Total area of cloth required is the cloth required to make the tent. This one, 22 into 10 into 6 plus wastage. Okay, so what is the total area here that we have calculated? This comes out to be 1452. This is 1320 plus 132, which comes out to be 1452 meter square. This much cloth you require with wastage. Now when you are going to a shop to purchase the cloth, they will give you the cloth in terms of area, in terms of length, because whatever cloth that you are purchasing, the width is a standard width. Okay. So here the width, the standard width that is given to you here is 2 meters. Okay. That means the roll of the cloth has standard width 2 meters. You only need to specify the length of the cloth that you require. So suppose L is the length of the cloth. Then what is the area of cloth required? You have taken the length to be L. Suppose the length of, you go to the shopkeeper and you say that you require so many meters of cloth. What do you mean by so many meters of cloth? He has a standard width. Okay, he has a standard roll of cloth with he has a roll of cloth with a standard width. So you only mention to him the value of L, which we don't know here. So area of cloth required here is standard width 2 meters into L, which is 2L required. So therefore, this 2L must be equal to total cloth required, which is 1452. And therefore, what is the length here? 1452 divided by 2, which is 726 meters. This much of cloth is required. Okay. But, and once we have determined the length of cloth required, the question here is find the cost of canvas at the rate of 80 per meter. So what is the cost of this canvas? How much canvas are we requiring here? We are requiring 726 meters of the canvas. So therefore, what is the cost of the canvas required? 726 into 80. This is the cost of the canvas that is required. Okay. So this comes out to be rupees 58080. 58,080 is the price of the fabric or the canvas that is required. Okay, any questions on this problem? Any questions?
No, sir.
No, sir.
If not, then you can read the next problem also.
Yes, sir.
Next problem would be, yes, this one. When a right angle triangle is rotated, revolved in fact, about any of the side, but remember, not about the hypotenuse. The right angle triangle is not rotated about the hypotenuse. The right angle triangle is rotated about the perpendicular or the base, but not about the hypotenuse. If you want to make a cone, it has to be rotated about a side that is different from the hypotenuse. Okay. So if you read this question, a right angle triangle whose sides are given to you here, 8 centimeter, 6 centimeter, and 10 centimeter. This is being rotated. Okay, about the side which is of length 8 centimeters. So this is your right angle triangle. Okay, and the lengths are given 8 centimeter, 6 centimeter, 10 centimeter, ABC, and this is being rotated about this side. So this side is your axis, in fact. Okay. So this side is your axis. Okay, 8 centimeter. This is being rotated. That is, this is rotated in this way, and a cone is generated. The question is find the volume and the curved surface area of the cone. Okay. So now can you tell me which one should be the height of this cone? Let me hide this a little. Okay. Can you tell me which one should be the height of this cone? If this right angle triangle is being rotated about AB, 8 centimeter side, then what should be the height of the cone?
8 meter centimeter.
Say
8
8
centimeters.
meter, 8 centimeter.
So this becomes your 8 centimeters. And what should be the radius of the base?
6.
6. This side entirely becomes the radius of the base. Okay, 6 centimeters. Okay. And what should be a slant height? Slant height becomes 10. Okay. Now you can find out the area, curved surface area, whatever you want, because you know everything. So what should be the volume? Volume of the cone is 1/3 pi r square h. Value of pi they have given 3.14. So we put 3.14 into r square into h. Okay. So this is, you have to multiply everything. In fact, uh, maybe this 6 will cancel. 1/3 into 3.14 into 6 into 6 into 10. So this will cancel here. Okay, so you multiply all this and you will ultimately get 301.44 centimeter cube. This is the volume. And next question is find the curved surface area. What is the curved surface area of this cone? Pi RL 3.14 into radius 6 and slant height is 10. So this comes out to be 188.4 centimeter square. So that was easy enough. Okay, but you have to visualize. Okay, and now we come to the next question, which is a little difficult because this making a cone out of a sector of a circle or uh, a semicircle, that actually becomes a question more of a visualization. Okay, if you are able to visualize properly, if you are able to remember that video, or in fact what you can do is you can at home you can practice making a cone. Or if mostly if you have seen these jhalmuri walas or these people, they are actually experts in making cone out of these papers. So if you see them making, maybe you can visualize them making this kind of a cone from this paper. So if you see the question here is a semicircular lamina of radius 35 centimeter is folded so that the bounding radii are joined together to form a cone. So you have a semicircular piece here, and this is being made into a cone. So this is your center. Radius here is given to be 35 centimeters. This is being made into a cone. So if you look at that video that I have sent you, or if you can visualize it in any way you want, then you will realize that the slant height here will become 35 centimeters. Radius becomes the slant height. Okay, and the length of this arc, this semicircular arc here, this length, okay, this becomes your circumference of the base of the cone, right? So what we are going to do here, since we know the slant height, and what do we have to determine? We have to determine the radius of the cone first. Suppose the radius of the cone is r. This is the height of the cone. We want to determine r. So can we find out the this height here? What is the height of this cone? If we know r, in fact, the question is to find out the radius of the cone. That means if you have to find out, you have to find out the length of this arc first. So length of, let us call this AB, and let us call this AB. Length of the arc, length of the semicircular arc AB must be equal to circumference of the base of the cone. Circumference of the base of the cone. Okay, so length of the semicircular arc. And what is the length of this semicircular arc? Length of the semicircular arc is half of 2 pi r. In fact, not this r. Let me just half 2 pi. And what is the radius? Let's not write r because r I have written here. This r is different from this r. So r here is 35. Okay, so this becomes your 35 pi. You can put the value of pi also, 22 by 7. Okay, so this becomes 110 centimeter. This is the length of the semicircular arc. If r is the radius of the cone, if r be the radius of the cone, radius of the base of the cone, therefore what you see here is circumference of the base is 2 pi r, which must be equal to length of the semicircular arc, right? So therefore from here you can determine the value of r. So r is equal to 110 by 2 pi. Now put the value of pi. Okay, now you can cancel. You get 35 by 2. Okay, so this comes to 17.5. This is the radius of the base of the cone. Okay, and the next question that we have here is, once we have found out part 1 radius of the base, the lateral surface area of the cone. What is the lateral surface area of the cone? Lateral surface area means curved surface area. Lateral surface area of the cone, what is the formula? Pi RL. Pi RL. So pi here is 22 by 7. Radius we have calculated this to be 17.5, and L here is 35. Now this becomes 2.5. So this is 22 into 2.5 into 35. Okay, and this should, once you multiply, this comes to 1925 centimeter square. Okay, any questions on this?
No, sir.
Now see number 8, this problem that is there after this problem number 8, actually this problem is a problem from something called as the frustum of a cone. Frustum. Okay, and frustum was never there in your syllabus. Okay, now this was a special problem. You can go through this problem. This problem is actually somewhat out of the syllabus, you can say. So if you are, but if you are interested, you can go through this very interesting problem. This is, I just wanted to solve this problem to get a kick.
Sir, what is frustum?
Huh? Frustum of a
Sir, what
cone.
was
If you cut a cone from the top, then whatever figure that you obtain, that is called the frustum of a cone. Let me just draw this for you. Say if you have a cone, and what you do is with scissors, you cut out this part. Just cut the top part. So what is the kind of solid that you obtain? You obtain this kind of a solid. This is called the frustum of a cone. It's called the frustum of a cone. Okay. So this is actually this next problem number 8. I solved it for myself actually, not for you. But if you are interested, you can go through this. Very interesting problem this is. Okay. So I stop here for today. And the cones, I think the whatever problems I have discussed here,